Building Docker containers takes tens of minutes on every code change, forcing tedious full rebuilds that slow your workflow. This lecture on Docker builds and pipelines shows how advanced caching and CI/CD integration slash times to seconds. Hi, I'm Martin, DevOps engineer and your guide through this talk. From my experience with Kubernetes ephemeral containers, I've faced builds failing due to internet outages, non-existent caching, and artifact repository issues, plus security risks from running root containers with excessive privileges. This talk covers how Docker BuildX with Nexus solves these problems, why persistent pipeline machines beat ephemeral ones, which artifact repository to choose, and how Docker BuildX accelerates builds, and how to secure your containers properly. Here's a real example of how I reduced build time from 2 minutes down to 16 seconds, but depending on your project, you could easily cut it from tens of minutes to just 1 minute. The biggest advantage of using a persistent LXC machine with Docker BuildX is the cache. It dramatically speeds up your builds by reusing layers across runs. Does it really matter if the pipeline runs slowly? Yes, slow pipelines kill developer productivity. Waiting tens of minutes per build means hours lost daily across a team, delaying feedback loops, increasing context switching, and frustrating everyone involved. Faster builds with Docker BuildX caching enable rapid iterations, quicker bug fixes, and smoother CI/CD flows, turning development into a competitive advantage rather than a bottleneck. In the old Kubernetes-based solution, every pipeline run launched an ephemeral pod that was completely destroyed upon completion, erasing all data, caches, and temporary files. There was absolutely no cache persistence, forcing the entire Git repository to be downloaded from scratch every single time, which dragged out build times unnecessarily and burned through bandwidth. The setup demanded complex YAML configurations and cluster-specific tweaks, while debugging across distributed logs felt chaotic and inefficient. Although the non-persistent data offered a security benefit by leaving no traces, Docker in Docker ran with full root privileges, creating unnecessary risks and vulnerabilities in an already frustrating workflow. Let me walk you through this live demo of running Docker in Docker directly in a Linux shell. It's a perfect illustration of the hidden dangers lurking in traditional container build setups. As you watch on screen, I start the Docker in Docker service, and it spins up a container that looks nicely isolated at first. Dependencies install, builds kick off, and everything seems smooth without immediate red flags. But here's where it gets concerning. When we run docker inspect on that container for a closer look, process ID 34438 exposes the ugly truth. This process isn't sandboxed away. It's executing directly on the host system, running under the root user with unrestricted privileges. That means your supposedly secure build environment has full access to the host's file system, network, and resources, turning a routine pipeline step into a wide open door for privilege escalation attacks that could compromise your entire server or cluster. The new approach uses a persistent LXC container as your dedicated build machine, offering much simpler initial setup. No more wrangling Kubernetes YAML or ephemeral pods. Everything stays cached across runs, from Git repos to Docker layers, enabling lightning-fast builds like my example of 2 minutes down to 16 seconds. Debugging becomes effortless with direct shell access and persistent logs without the chaos of distributed systems. Data persistence trades some security isolation for speed, not ideal if compromised, but Docker BuildX runs securely without root privileges, avoiding Docker in the Docker risks entirely. GitHub Actions Runner in LXC. The GitHub Actions Runner in this setup works inside an LXC container with the working directory placed under the work folder where each job checks out and builds your repository. You can connect to this machine just like to any other server, for example over SSH, which makes debugging and manual inspection straightforward. Because LXC is much more lightweight than a full virtual machine, the container only consumes significant memory and resources when the runner is actually doing work, keeping your infrastructure efficient. As you can see in the current demo, my LXC container is running a GitHub Actions runner configured with two distinct network addresses, one internal address dedicated to Docker's communication needs, ensuring smooth container operations within the isolated environment, and a second public-facing address for external access. Despite this dual network setup, I can connect directly to the container's console anytime, using a simple LXC exec command, which gives me full hands-on access for troubleshooting or inspections. When we navigate to the Actions Runner directory under the Home folder, we find the work directory right there, holding a complete copy of the Git repository that's persistently cached and ready for use across multiple builds. Docker BuildX harnesses BuildKit running securely on the host server through Rootless Kit, which is a clever tool that allows the entire BuildKit daemon to operate completely without root privileges. This is a game changer for security, unlike traditional Docker in Docker setups that demand elevated permissions and expose your infrastructure to risks. Rootless Kit sandboxes the process effectively while still delivering full build capabilities. Once BuildKit starts up successfully, the next critical step involves tweaking the socket permissions explicitly, typically using commands like commod or adjusting ownership, so the socket becomes accessible from inside the LXC container where your GitHub Actions runner lives. All of this socket and daemon configuration gets defined cleanly in the buildkit.toml file, giving you fine-grained control over listening addresses, worker settings, and more. For practical implementation, I've shared complete example configuration files on GitHub that you can grab, adapt, and deploy right away to replicate this setup in your own environment. As you can see in the image on screen, I'm launching BuildKit through Rootless Kit to keep everything running securely without root privileges. This setup starts the daemon in a sandboxed mode that isolates it from the host system while still providing all the power needed for advanced Docker builds. Right after startup, using the exec start post directive in the service file, I automatically adjust the socket permissions for the BuildKit socket, making it fully accessible from within the LXC container. This one-time tweak ensures your GitHub Actions runner can connect seamlessly without manual intervention every time. LXC configuration for BuildKit proxy. Take a look at this LXC configuration snippet where I've defined a proxy device specifically for the BuildKit socket. It acts as a secure bridge between the host machine and your container. Here's how it flows. The connect line points to the actual BuildKit socket file on the host at buildkit.sock, while the listen line exposes that same path inside the LXC container, all tied together with type proxy. This setup tricks the container into thinking BuildKit is running locally, giving your GitHub Actions runner full, transparent access without any complex networking or service duplication. BuildKit daemon itself has to live on the host machine, not for extra security layers, but simply because it can't run natively inside LXC due to kernel and privilege limitations with rootless mode. The proxy handles tunneling all the communication seamlessly into the container, which is why we run that exec start post command right after startup to tweak the socket permissions. It ensures the non-root processes in your LXC-based runner can read and write to the socket without hitting access denied errors, keeping builds smooth and reliable every time. Sonatype Nexus fits perfectly into Docker BuildX workflows within CI/CD pipelines, starting with its free version that lets you host a private Docker registry right alongside your persistent LXC runner. You'll need to handle custom certificates for secure HTTPS access, but once set up, BuildX can push and pull cached layers directly to Nexus, turning slow full rebuilds into lightning-fast incremental ones. This integration supercharges your CI/CD development pipeline by caching not just Docker images, but also APT repositories for Debian or Ubuntu. Imagine pulling dependencies in seconds instead of minutes every time a job runs. With persistent storage on your LXC machine, Nexus eliminates internet flakiness or repo outages that plague ephemeral Kubernetes jobs, accelerates feedback loops for faster iterations, and keeps all artifacts centralized for easy debugging and rollbacks, ultimately slashing total pipeline times from tens of minutes to under a minute. Sonatype tips and tricks. When integrating Sonatype Nexus with Docker BuildX, you can't reference it directly in your Docker file using standard registry URLs because custom certificates need proper configuration first to establish secure connections. The workaround involves manually installing the certificate management package from the internet ahead of time. This ensures your build environment can trust and connect to your self-hosted Nexus independently, avoiding reliance on flaky public internet during actual CI/CD pipeline runs. To supercharge your Docker builds with Nexus, create a custom-based distribution image, for example starting from Ubuntu, where you've pre-configured the APT system to proxy all package requests through your Sonatype Nexus repository. This means baking in the custom certificates and repository sources directly into the base image, so every derived Docker file inherits a ready-to-go environment without extra setup steps. As a result, package downloads during builds become dramatically faster instead of hitting public Ubuntu mirrors over the internet prone to slowdowns or outages. apt-get pulls cached artifacts from your local Nexus in seconds, shaving minutes off each layer and making CI/CD pipelines blazing quick while staying fully independent of external networks. Thank you all so much for your attention and time today. This wraps up our deep dive into revolutionizing Docker builds with persistent LXC BuildX and Nexus for blazing fast, secure CI/CD pipelines. If you want to dive deeper into the configs, examples, or my other DevOps projects, please visit my website at www.martinkonisek.eu, where you'll find direct links to my LinkedIn, GitHub, and a treasure trove of articles, tutorials, and code samples. Thanks again, and happy building.